the DMTL evaporator system for European imports, and it's also used by Mazda. Now, like Toyota, this system has an electric pump that's going to be used to look at the flow. And like Toyota, we're going to feed it into an orifice. Here's our orifice over here. We have a 0.5 and a 1 millimeter orifice. We're going to feed it in these two different size orifices to detect two levels of leaks. And what we're going to do different here, though, is we're not going to measure the vacuum the way we did in Toyota. This system measures the amp draw of the electric motor for the pump. Let's talk about what's going to happen to the amp draw in a pump. A large leak will have a low, steady amp drop. It'll drop, it'll come to a point, and the RPM won't change and the amp draw won't change because it's not developing much of a vacuum. A small leak or no leak, as we pump a vacuum up, amp draw will increase and go up higher and higher to reach a maximum point. The higher the amperage draw, the more vacuum we're developing, and we're going to compare that back to our 1 millimeter orifice to see what it looks like. Let's have a look at what the time duration. We've got three different conditions here. The bottom, where it goes down, is black and red. That's a leak larger than 1 millimeter. Once we get the pump up and stabilized at the first page, and then we switch it into the pump, into the system, we see current starts going down, and we start looking at this system, and it stays flat. It's not building any vacuum. The middle line is a 1 millimeter leak. It starts off very like we had before, but you can see it starting to build a vacuum. At the end, we judge it by how much we've built up a vacuum out at the end. How long this is determined by the temperature conditions all set up by the computer. A tight system is the green one on top. As we build it, the amperage goes higher and higher and higher, indicating a larger and larger vacuum being developed. It's sealing very well, and we've passed our benchmark. We had our 1 millimeter leak up there at the top, but we stabilized. That's 1 millimeter. Then we switched it back into the tank, and we watched current flow drop initially because we're going into a tank that has no pressure or no vacuum. And as we build a vacuum, current starts increasing. The ending tells us how much vacuum we have developed. With a big leak at the bottom, red-black, we have very small or no increase. The red in the middle, we have a 1 millimeter leak. It comes back to our 2.5 kPa, which is what we had calibrated it for when we looked at the orifice. So we calibrated it for 1 millimeter orifice. There's a 1 millimeter leak. They come to about the same point. When we had the good system with the small leaks, the green trace, the current went much higher and built up to higher level, indicating we have a leak, no leak detected, or a leak so small we can't measure it. So this works with current flow. All of them do the same thing. We're trying to check for leaks.